Hello, video number 21. This time we will implement two things. One is the iterative deepening. But first we will look into something called the killer moves. And the idea with the killer moves is that on every ply, on every depth, we keep two moves that proven to be good, and we try then on the sibling nodes, because there is a good chance that these moves are strong even there, but there is also a risk that these moves are not even legal in another position, so we need to be careful with that. We can restructure the to-do lines here a little bit. These things are done, and we move the killer and history up to here. The stop is done. Can be like this for a while. And now, in order to use the killer, we need to sort them high up in the move list. So we need another move generation instead of gen and sort. So it takes we go down here and place it close to the old one. Gen in order, and we take the board and we take move list and the ply. We need the ply. We start to clear the move list. Move list, it should be the move list. And then we can generate all the captures first. So in this case we put all the captures on top. Not optimal, but we will do that for now. And the no capture X is the length, because now we are generating all the non-captures. We don't have these functions yet, but this is how we will do. And after that we will place the killer moves high up. We don't have the functions and we don't have the killer moves yet, but it will be clear. So we need to know there is some space to put the killer moves. So we place the killers first after the captures. So we need to go through the move list, and we can start with no capture X, and we loop through all the non-captures. And we check if the current move in the list is equal to killer move. So we have this killer table with killer move 1, and we check if it's the same as the current move in the move list. In that case, we use this nice go function to replace the two entries in this move list. So we put the killer move high up and the other move where the killer move was. It can be the same move, but it doesn't matter. And the same with the second killer, and we place it on the second place. So capture moves first, then killer moves, then non-captures. So let's create some functions. Here we have the generate functions. Okay, so in order to generate captures, we need a move list, of course, but we need to have all the opponents pieces, and we put that in a bitboard, op bb, and we can use that. And then we generate all the pawn captures. They already use. They don't need to know who are the opponent. It's built into the function. And we do the same with knight moves. But here we tell knight moves that we will use only the opponent's bitboard. So it's only captures. And knight moves. And the same we do the same with all the pieces. And in fact, generate all non-captures is more or less the same thing. None. And it's not opponents, it's the empty squares on the board. And we put them where opponent bitboard is, we put the empty. Okay, so there are a few things to know about killers. First, we will save killer moves whenever we find some moves in the search that we find is good, strong. In fact, it's a beta cutoff, and we save it as a killer move. And also, we never save killers if they are captures, because captures already get high up in the move list, so we don't need to save them. And also, if it's a promotion, we don't save that. We just have non-captures in the killer table. Now let's define the killer table. It's quite simple, and that's the good thing with killers. So we can place them here. It's a very simple table. So we have a killer struct, and can say that the killer struct holds the killer moves per ply. So we define the killer struct, and it's an array of max ply killers. And max ply is 100 right now. So we have K1 and K2. These are the killers. And how to add the killers? We use a function here. Avoid checks, captures, and promotions. So we have an add function, and it just take a move and apply. And here is the add function. We see if the move that we send into add, we check if it's the same as the killer one. If it's the same, we just skip it because we have it already. If it's not the same, we put the killer 1 move down to the killer 2, and then we put the new move into killer 1. We need a clear function as well. It just put no moves in all of the killer table. It should be killers, not X. Okay. We can comment out the old move generation. And here is the beta cutoff. And that's the place for killers. So if it's not a capture and it's not a promotion, then it's a killer. And this returns cursor should be outside, yes. And something is wrong here, right? Okay, so the killers are done. And actually I changed my mind about the history table. We put it down in the to-do list again because it's related to the more accurate move generation function that we will know. Remember that the move generation we have right now is just temporary. Let's go to the root node and do some iterative deepening. So what is iterative deepening? Yeah, it sounds very stupid, but it's not. It's very clever. First of all, we will search the tree for each depth, starting with depth 1. So we make a search for all the root moves, depth 1, and then all the root moves, depth 2, depth 3, depth 4, and so on. And we actually do the search faster. And how can that be? Well, it's because move ordering, because move ordering is everything in alpha beta, almost everything. And it's also a way to have a much better time. It's much easier to have a good time handling when we say to think for 10 seconds, for instance. We don't know how deep we can search, because if we go too deep, we don't have the time to search through all the moves in the root node. By doing iterative, we come down to a certain depth and we break when the time is out. Excellent. So we can comment out this depth, because we will start with depth 1. For depth equal to 1, as long as depth less than the limits depth, and we increment 1 to depth for each loop. We no need to change anything in the search. So we will loop through depth 1, 2, 3, 4 until time is out, or maybe something else will stop us. And we make a sort of the move list after each iteration, and that will give us a great move ordering. And also down in the tree we will get a much better move ordering. Now we will finish for today and see you next time. Bye bye.